Okay, we're on to chapter 15, which is freshwater systems and resources. This is going to have a lot of memorization for water treatment and wastewater treatment. So when we get into those sections, it'll be a lot of memorization. So first things first, we are going to take a look at the breakdown of our water system. So know the definition of fresh water, which is basically water that has no salt in it, and what's going on with water on Earth. So only 3% of the water on our planet is actually fresh water. Of that 3%, 2% is locked in glaciers. So really we only have 1% of water that's truly available for humans to use for drinking consumption. So we have to be very careful with that water that we do have. No surface water, groundwater, aquifers, water tables, so those particular words. Surface waters are your rivers, streams, and lakes, so anything up on the surface. Groundwater is exactly what it sounds like, anything that's found under the surface. Aquifers are particular areas where we have porous rock, sand, or gravel, and those areas actually hold water in those pore spaces between the rocks and gravel and sand. And we use that to pump out and consume as drinking water. The water table is the point underground where all of the pore spaces are completely filled with water. So that's the water table. Aquifer and recharge zones are essentially the watershed. So here, we'll come over here. So here's your aquifer, here's the well that we're pumping that water out of. So recharge zones are the watershed that feeds the water through runoff down into the actual aquifers. It replenishes those aquifers. The artesian aquifers are any type of aquifer that's actually surrounded by impermeable rock layers and can flow naturally under pressure due to that sandwiching of the rock layers. So make sure you understand what runoff is. Again, watershed. Runoff is any precipitation that we have that goes off the surface and goes into the water systems, whether that's the ground, the rivers, the streams. And the watershed is all of the land that drains into a river. So the watershed for the Mississippi River is huge. It spans from pretty much the Appalachian Mountains to the Rocky Mountains. That's the watershed for the Mississippi. One important aquifer to know about is the largest aquifer in the world. And this is actually going to span from Nebraska to New Mexico. It's a huge, if you take a look at this map, here's South Dakota, New Mexico. This is one of the largest aquifers, so it's the largest amount of rock that holds water underground. And we're pumping a lot of this and depleting it due to our agriculture. If you look at these states, Nebraska is a huge agricultural state. Kansas is up there too. Some of these other states have more cattle farming, Texas. So we're actually pumping a lot for irrigation and agricultural use. So some characteristics of watersheds are the area, how big of an area it is, the length, and the slope. So again, I told you the Mississippi River's watershed goes from the mountains to mountains on either side, and that's due to the slope. The slope of those two mountains feeds down into the Great Plains, and that's right where the Mississippi River will be located. We also see different types of vegetation and basically the wetlands that join up to it. So the Chicago River will eventually feed into the Illinois River, which feeds into the Mississippi River, and so on and so forth. So know the words for what floodplains are, tributaries, all that fun stuff. Again, some of the tributaries for the Mississippi River are the rivers around us here, the Des Plaines and everything else. So riparian is basically anything that has to do with a river. That's just those types of environments. Ponds and lakes are important to understand as well. You need to know the layers of the ponds. Those are listed right here for you. And we have the littoral, which is basically the shoreline. The benthic zone is the bottom, so B for bottom and benthic, which is the low amount of oxygen in that area. Limnetic, think of like a lumen would be light. So the limnetic zone is the open layer with sunlight. It has a lot of photosynthesis occurring. And then we have the profundal area, which is the area that light doesn't really reach. That's that mid zone right in here that's not completely benthic, but not photic. Okay, so know those layers. Remember eutrophication from the last unit. It can also happen in lakes. So more nutrients from the runoff of fertilizers will choke out the plants when they start to reproduce. Any lake that has low amounts of nutrients in it is going to have a lot of dissolved oxygen, which is great, you'd think, but actually because it doesn't have nutrients, there's not a lot of plants. So those lakes are usually really clear, but there's not a lot of life because without plants, you're not going to have consumers and so on and so forth. So we call this biological oxygen demand. Things demand oxygen. Living things demand oxygen. So that's the amount of oxygen that's needed for decomposers to break down dead organic matter in the water. If that oxygen isn't there, then the dead stuff doesn't go away. And I'm not going to lie, if bacteria can't survive in that location, not much else is going to. Okay. So wetlands. Wetlands are systems where soil is saturated with water and has plants that grow half submerged in water. So there are different types of wetlands. We have the fresh wetlands called bogs and marshes, and there are marine wetlands actually. If they're on the coast, we call them estuaries, or salt marshes, or mangrove forests if they're in tropical areas. So they're really important for us. They have a lot of environmental benefits. So the crazy thing with them, they increase biodiversity with a habitat. They do a lot of photosynthesis. They are the base of a food web. They can clean and filter wastewater, so they filter a lot of toxins and sewage out of water. They're a recharge zone for aquifers. The water will run off and eventually it slows and infiltrates into the water table. And they're a nursery for a lot of species. There's a lot of species that actually lay their young there because it's, a bit protected. The economic benefit of a wetland or the ecosystem services also that it gives us. Remember, on FRQs, when we discuss economic benefit, you have to discuss money or jobs that correlate with that. So flood protection from hurricanes and storms, tourism, which would produce jobs and money for the people working there. It can recharge their aquifer, which is great for us. Wastewater cleaning, so we don't have to build more wastewater treatment plants in some areas, which is great. But we are threatening these watersheds and wetlands. We're draining them and filling them to develop agricultural land or just houses. We're building roads and bridges over it, which is actually causing more air and water pollution from the salts, from the oil and other gasoline that might be running off of our tires and our cars. And there are invasive species that are actually being added to wetlands. One would be like the Burmese python in Florida. People were buying them as pets. They were getting too big. They dump them in the Everglades. And now, because there's no native species for them or no predator, they're out competing the native species. And they actually have hunters out there to kill these pythons. So we take a look at the map of water. Asia has the most fresh water, but it actually has the lowest per capita because of how high the population is in Asia. So we call water consumption either consumptive or non-consumptive. Consumptive water use is stuff that's not going to replace the water back into the system right away. Agriculture, it sits then into the plant, or us drinking the water. That process, the water stays in us and it doesn't go back into the system. It then goes to a sewage facility or something else. Non-consumptive would be removing that water temporarily and returning it back. So pumping water out of an aquifer to water your lawn, it's going to go right back down. The last chapter we talked a little bit about aqueducts. Aqueducts are man-made rivers to carry water from one area to another. They're actually used heavily in California. They try to get melted snow also down from the mountains, or they get water from the Colorado River in southern Florida or California. So they are moving water like crazy. We're skipping ahead quite a bit. How do we reduce our water consumption? We use low flow water appliances. You know, like the toilets that you can go up for a big flush or a small flush. Turn water off when you're brushing your teeth or when you're actually like running the shampoo through your hair. You can eat less meat because livestock requires a lot more feed and water. If you think about it, you have to water the plants that create the feed for the cow, but you also have to be watering the cow at the same time. So those are different ways to reduce your water. So there's so little fresh water that we actually could do processes like desalination to remove the salt from the water, but it's expensive, it requires a lot of energy, and really we only see this in wealthy oil-rich nations where water is scarce, so not really around here. But again, to reduce our water loss, you can do stuff like harvesting your water using rain barrels. Gray water, which is basically your dishwasher, your showers, your sinks, all that water then gets run to a special pipe, and you can use that to water your lawn or golf courses because the soap is diluted enough, it's not going to damage anything. Or we can do xeriscaping, which is basically planting landscape that's drought resistant. So a lot of the warmer climates do that. They remove grass because they really don't have the ability to be watering it. And they put in rocks and plants that can resist water or don't need it as often. There are two different types of pollutions that are around. There's something called point source pollution and non-point source pollution. Point source is something that you can actually say, this is what's adding the pollution to the water. I can point to it and I can confirm it. Non-point source is a bunch of little sources that might mix together and it's not really one thing. So that neighborhood or, all those cars. There are different types of pollution that can actually feed into it. Your book goes through quite a bit. So toxic chemicals like heavy metals and mercury, pathogens and diseases. That's disgusting. Those will come from animal waste or human waste. You can have toxic or industrial mining waste. There's biodegradable waste, so like litter, your lawn clippings, anything like that. And that actually can block the intestines of organisms, choking them. You could have sediment as a waste, which that sediment runs off through runoff and can cover up the light, so primary production starts to drop. Predators can't really see well, and that disrupts the habitat. And we can have thermal pollution, and thermal pollution again would be a warmer water source feeding into a colder water source. Sometimes this happens coming out of factories or nuclear power plants, and that temperature difference can affect the organisms as well as the dissolved oxygen, because warm water doesn't hold as much oxygen as cold. So here are some pictures again of point source versus non-point source. So we can say, yes, this factory's pipe definitely is contributing right here. This farm, it's running off right here versus the entire farm and golf course and neighborhood over here or the mining location. So we'll get into oxygen sag curve in a different video, but it goes into the dissolved oxygen and the BOD demands as well. Remember, BOD is the amount of oxygen needed to break down organic stuff. So we will see that. The Clean Water Act gets into a lot of this. It's illegal to discharge from a point source without a permit. Now, people are getting this wrong. You can still pollute into a river. You have to have a permit. It's illegal to do it if you don't have the permit. Pretty twisted, isn't it? The Clean Water Act did set some standards for industrial wastewater, and it set standards for surface water and contaminants as well as funds wastewater treatment plants. So one way that we treat water is through a water treatment facility, and this is going to clean your water that's going to go right back for drinking water. So water is pumped through screens to remove large debris, and then we call it flocculation, which is basically it's used in muddier, sediment driven areas. This clarifies the water using a precipitate like aluminum hydroxide, and it basically clumps up and moves that sand and sediment out. We zap the water with ozone or UV light to kill any of the bacteria. We used to use chlorine, but that wouldn't kill all the bacteria, so they went to UV and ozone. Then the water gets filtered through sand and gravel just like it would in the normal natural ground in a sedimentation basin, and that removes the dead bacteria that we've killed in the process of zapping it. And it also, the sludge that's found at this point can be sent off to farms and be used on farms. And then we store the water in water towers or other locations, and we disinfect it with chlorine just a little bit before we send it to your home, and that prevents bacterial contamination in pipes. And that is how your drinking water gets cleaned and then resent back out. Now, the other type of water is a little bit different. There are different steps with that water. So the water that gets flushed through a toilet needs excess treatment, and that goes through several steps. So steps 1 and 2 are the primary treatment. Steps 3 and 4 are secondary, and this is the tertiary treatment. Not everybody in this country does all these steps. So if you look at the breakdown here, it'll tell you. We take a look at that here. Let's put the steps here as well. But water is pumped through the screens, just like in the other one. Large material like plastic, leaves, sticks, all that stuff gets removed. They also turn it as well, and in this process of turning, heavier things sink to the bottom, oils and fats rise to the top, and then they use a skimmer. The oils and fats and the skimming process, again, can get sent away to be used as fertilizers later. When we pump in oxygen at this next step. Remember, oxygen is great for bacteria. Bacteria then start to do their job. So the bacteria start to speed up and break down and decompose any organic matter that's left in the water. The sludge then is processed and shipped to non-food farming. So your cotton and those types of plants. We don't want to put this type of waste material sludge in food. That's how we get E. coli outbreaks. Sometimes we do add another clarifier to remove more solids and oils. Then we have the sand filtering, just like before. Filters through the sand, disinfected. The effluent is discharged into a waterway at this point, like a river, ocean, or stream. They add chlorine to kill all the remaining bacteria and neutralize it before we dump it. So we don't want to pump that straight out into the lake with chlorine in it, so we actually neutralize the water. And this is considered reclaimed water at this point, but we don't want to drink it. So because people are too afraid to drink it after this process, we pump it into like a river, and then eventually it gets filtered through the groundwater system again and clarified naturally. Some people don't have this luxury. They have septic tanks in rural areas. Basically, this is a tank that's found underground. They dig it down. Bacteria decomposes the organic matter, and slowly the liquids will start to leach back into the ground and naturally filter into the aquifer. Sometimes certain locations will actually pump out the water halfway through the process, and it will go into a marsh, and the marsh will take care of slowing down, removing the last bit of toxins and bacteria, and then sending the water essentially through the final treatment that's needed. When water runs off of our streets, it gets into storm drains, and that flows directly into rivers, oceans, etc. all the trash, bacteria, and toxins, and it's not being treated. So we have to be aware of what we're placing and running off of our driveways, because that's eventually going into the oceans, lakes, streams near you, and can be a problem. So in a lot of places they put those rock mounds to slow water down and capture things, or screens over storm drains to prevent the materials from actually entering the larger bodies of water. And this way then can increase infiltration and reduce the runoff. So those are different processes as well.